Get moving. So thanks again for joining us today. As always, this webinar is being recorded. It will be uploaded to our YouTube channel, where you can find on Spear's website, eepartnership.org. And under the news section, you'll find it on our resources page. And on the resource page, you'll find a link to our channel, or you can go to YouTube and just search Spear, S-P-E-E-R. Within 72 hours of today's presentation, you'll receive a course evaluation email from Kathy Lawrence. Please complete the survey and send it back to her. You'll receive your course completion certificate that contains the course ID and title that you'll need when reporting your CEUs to ICC. As kind of our rule, you have to be at least 3/4 of the time of the webinar to get credit. Lastly, we have the chat feature is open. Report any technical difficulties you may be experiencing during the presentation. I also have the Q&A feature open as well, so please use that to post any questions you might have as we go through the presentation. I'll try to try to answer them in real time. So let's get started. If you missed the first section or the first part of this 2024 IECC significant changes and what we know so far, if you missed that, it is already up on YouTube. You can watch that after this one. So let's get rolling through it. This is part 2. We're going to end up basically on our agenda talking about the rest of chapter 4 and then chapter 5 and then some appendices. So there's a lot of information here. It's going to take up the majority of the time. I'll try to go a little slower so we can get some important information across. So if you're first time visiting or first time with us today, we're one of 6 RIOs. It's an regional energy efficiency organization. We're member-based, we're nonprofit, we're a 501c. 50 plus members across a wide selection of energy efficiency industries like product manufacturers, other nonprofits that kind of use us as the litmus test of what's happening around Texas and Oklahoma. Our focus is for outreach of education and collaboration in clean energy. So I appreciate it. I can help with anything from trainings, the webinars, of course, in-person field training, as well as like a one-on-one IECC test prep if you're looking to get certified as well. I'm happy to help in any way that I can. So the 2024, and kind of looking at this new design for the 2024, we've talked about it in our previous webinars, but it has changed to an ANSI process standard or standard process to where it's updated. There's more subcommittees involved. There's more public input involved. So going through the 2024 and seeing a lot of these changes that have happened and added or have been tweaked or added additional comments to it is a lot of it's based on open to the public and people that have a lot of experience, from product manufacturers to building science to people that's been in this industry for a long time. So they're able to give their input and have subcommittees vote on it and actually talk about what makes sense to the code. So you'll see some things. It's going to be kind of confusing for some people. We looked at the tables last week or 2 weeks ago. We looked at the prescriptive table. The R49 for climate zones 2 and 3 has now gone back to 38. So that gets confusing as to why they're going backwards. There's a lot of thought process behind that as to why things change. So we'll go through that, but as it's being said, residential and commercial buildings are responsible for approximately 40% of the U.S. consumption. Energy codes are one of the strongest tools for reducing energy and emissions in new buildings. Strong energy codes are also essential to the equitability of the energy efficiency economy because of a set of standards and all the buildings that they must meet that standard. So ensuring that no household or business or new building is left with needless high energy bills. So a lot of it's being brought into, and if you look at where it's going, used to be it was just energy consumption. Now we're looking at how to meet goals of greenhouse gas emissions and carbon footprint. Lowering energy consumption is one way to actually help meet those goals and offset some of that. So a lot of this stuff that's being put into the code, you can kind of see it's taking a little bit of a detour into more of a holistic, from gas emissions and carbon footprint and energy consumption as well. So as we said earlier, now we're going to get started with the meat and potatoes of it. If you have questions, by all means, post it in the question and answer or the chat section, and I'll answer it in real time as we go through it. So some of this stuff, as I go through it, I don't like doing this, but I'm almost going to have to be just reading off the slides. Some of this is new to me. Some of it I'm still learning from what is put in there, and I'm reading the behind the scenes, what the proposal looked like and what it meant and what their intent was and how it was proposed in the book and how it made it into the book. This is not yet published. It will come out in January. This is as closest to the final draft as I could get. So this is kind of why I'm adding this here. So there may be some changes, but not a lot probably. For blower door testing, it now actually drops the ACH to 4 as opposed to 5 ACH per condition square foot. There's allowances for smaller buildings drop from a 0.30 to a 0.22. Basically, it's a cubic feet per minute per square foot of the building envelope. So it's a different way of not doing the calculations for ACH, but it's a different way of reaching the same goal, but for smaller buildings. Anything less than 1,500 square feet can use this allowance to get to that number. It may mean that if you do the calculation, you're at 6.5 ACH, but being that it's a much smaller building, you're also having very small energy consumption. So the equivalent to that will be the 0.22 CFM per conditioned square footage of the envelope. If not, if you're following the ACH, it's going to be 4 ACH instead of 5, and that's for all climate zones for all pathways. However, there's still if you're going to use prescriptive, you must follow a different one, but most builders use performance. So testing exemptions, though, there is that exemption. It says when testing individual dwelling units, an air leakage rate of not exceeding 0.27 per square foot of the enclosure area, of course, reported at a 50 pascals difference shall be permitted for climate zones for single and multifamily building and dwelling units, buildings with units of 1,500 square feet or smaller. So it gives a different allowance with that. The exceptions get lengthier because there's different ways to look at things and how to navigate through what's actually being proposed and what's being done. But for heated and attached private garages and heated and detached private garages with accessories of 1 and 2 family dwellings and townhomes for not more than 3 stories above grade, it's starting to now look at if you have a detached or an attached garage and it's being heated, you're not using probably a full system, so it's not really being fully conditioned. It's being heated at some point to just offset being cold in the winter. So now they're addressing that with also looking at from air tightness envelope testing for those as well. And there's different criteria that need to be done. Of course, the inspector needs to inspect for the air barrier and insulation criteria, just as you would a regular home, and the envelope for it as well. But there's different things in different sections you have to actually meet and look at for that, and looking at different tables for the construction method being used. And then also we're tested in accordance to a different section. The testing of each dwelling is not required. So there's some exceptions there. You have to look at it and identify, am I meeting this exception? Can I be exempt from having to have this tested? So as I said a second ago, there's also a prescriptive call out that says when complying with sections 401.2.1, which is prescriptive, the building or each dwelling unit shall have a leakage rate not exceeding 5 ACH for 0, 1, 2, and then 3 ACH for 3 and 5, and then 2.5 ACH for 6 through 8. So in Texas, we just have anything from a 1 to a 4. So really that would get kind of a little bit confusing with if you're in 0, 1, and 2, you're at 3 ACH. And then if you're at 3 through 5, you're at 2.5. I'm sorry, you're 5 ACH for 0, 1, and 2, 3 ACH for 3 through 5. And then they break it apart with 2.5 ACH for the much, much colder climates. So looking at that part of it, it does get a little bit confusing where one said 4 ACH regardless of pathway or compliance. And then if you're using prescriptive, then you need to follow this this pathway here, or not a pathway, but this requirement. So there is, and I like to see that this came from the commercial side of this, but if you have what's considered a multifamily dwelling unit and it's residential because it's 3 stories or less, they've brought into this a dwelling sampling protocol. So for buildings with 8 or more dwelling units and greater of 7, you need to do greater of 7 or 20% of the dwelling needs to be tested. Testing units shall include 1 top floor, a ground floor, a middle floor, and then the largest dwelling with the largest enclosure area. Where the air leakage rate tested is greater than the maximum permitted, corrective actions need to be made and it needs to be retested. Then it also says for each unit that has a greater air leakage rate that's maximum, then you add an additional 3 units to be tested. But also that one that failed needs to be corrected, and then you need to test 3 more. And then where buildings have fewer than 8 dwelling units, all of those need to be tested. So before it was, if you were 4 stories or higher, you were commercial, there was a sampling protocol, but if you're 3 stories or less, then you're considered residential, and there was not a sampling protocol. So there was some confusion with the city would allow sampling, but it wasn't really in the residential allowances. But now they've brought this from commercial directly into residential to allow for a sampling protocol. That does include both blower door and duct blaster testing. It does not specifically call out mechanical ventilation, but some cities do go ahead and write a sampling protocol that fits the same thing we just read, also in mechanical ventilation. But since mechanical ventilation has to be tested in 2021, it's now, they're trying to get you not have to test every single unit for mechanical ventilation, but you follow the same protocol. If one fails, it has to be corrected, and you add 3 more to the sampling protocol or the sampling testing package. So to do it that way. So blower door, duct blaster is in the book. Mechanical ventilation, there's not specifically a call out, though most cities see that as the same. It's being tested just like all the other mechanical equipment. So you could do all 3 for sampling. So of course, if you're in an area that doesn't have an amendment specifically for that, you'll need to reach out to your building officials and ask for that clarification as to if that's going to fit a sampling protocol for mechanical ventilation as well. That can save a lot of money if you're doing residential style multifamily, and it doesn't, not all of them have to be tested. Gas fireplace efficiencies. All gas fireplace heaters have to be rated by an ANSI standard. It's Z21.88. Shall be listed and labeled, and its efficiency rating, or its fireplace efficiency, FE, needs to be 50% or greater according to the CSAP 41. And that is a testing method for measuring annual fireplace efficiency. It applies to all vented fireplaces and vented gas fireplace heaters that use natural gas or propane. So that's going to have to be done. So it's even calling out vented fireplaces. Of course, they're putting in parentheses decorative appliances. So it's, some people just look at it and go, well, that's just supposed to look like and mimic a fireplace, but it doesn't have a lot of effectiveness when it's heating. But if it's using gas at all and not just some electric version or just an electric heater, then it has to meet those requirements as well and have an efficiency rating for fireplaces. I left this on here kind of just stripped it out of the last draft. There's a lot that's been marked out. We've talked about it in previous webinars about confusion on electrical boxes needing to meet the NEMA OS4 standard. Really, the intent in the beginning was if you're going to use a manufactured air-sealed box, it needs to be tested for air tightness. Just like can lights has to be ICAT rated, so insulation contact airtight, they have to be tested and stamped or stickered to say they've been tested for air tightness. If you're using airtight boxes, they need to also be tested for air tightness and stamped in accordance to the NEMA OS4. However, they've kind of rewrote some of this and said air-sealed electrical communication outlet boxes that penetrate the air barrier of a building thermal envelope shall be caulked, taped, gasketed, or otherwise sealed with to the air barrier element being penetrated. But then it says air-sealed boxes shall be buried in or surrounded by insulation. Air-sealed boxes shall be tested. So it's again, you have to ask your building official how he reads this. My intent is if it's manufacturer made to be airtight, then it needs to have that stamp on it. If not, most cities just say you need to air seal your boxes. Even if they're the 19-cent electrical boxes in the wall, you need to caulk around that at the sheetrock level. You also need to seal the air penetrations on the back. So still a little bit gray on the area of that. However, in the table on this next slide, this is part of that prescriptive table, and you see everything in blue is all new or reworded. It basically just says electrical communication and other equipment boxes and housing and enclosures. The air sealing requirement is boxes, housings, and enclosures that penetrate the air barrier shall be caulked, taped, gasketed, or otherwise sealed. All concealed openings to the box, housing, or enclosure shall be sealed. The continuity of air barriers shall be maintained around the boxes, housing, and enclosures that penetrate the air barrier. Then it says, alternatively, air sealed boxes shall be installed in accordance to, and it talks about that requirement. So that's where I'm saying if they're air sealed boxes, then you need to follow that R402.5.6. Otherwise, this table is telling you how they need to be sealed. But just as we said a second ago, the insulation criteria to the right says it must be surrounded or buried by insulation. So squirting a bunch of polysil behind it does trap a lot of air bubbles. There is some insulation value to it. It will not be as much as putting a cut batt piece behind it. But if you're going to allow that and say it just needs to be filled up completely and have not just it squirted on the box, but a whole blob of polysil behind it can be adding as its insulation requirement. But it needs to be surrounded and buried. Of course, in manufacturer specs, we talked about it in the previous webinar, is needs to be cut to fit around the box, not just bowing around it. So it needs to be surrounding it with no gaps around the electrical box. But also these are very, very common. This happens a lot with these are the enclosures for your routers, for your phone cables, for your internet. All of it comes into here as a home run box. And I put on here, doesn't say this anywhere in the code, but in order to fulfill the requirements of what we just read, these things are 3.5 inches deep. So they should not be placed in the thermal envelope. They should not be on an exterior wall. They should not be on a garage wall because it's requiring you to put insulation behind it. If it's already 3.5 inches deep and it's on a 2x4 wall, you cannot get insulation behind this. This is a void in the building's thermal envelope. It needs to have insulation present behind it. So a lot of times we'd see people, if it was on a garage wall or an exterior wall, we'd ask for this to be sealed. But a lot of times the equipment installers say that's going to void the warranty because there is no air movement through the box to keep them from overheating. So in order to pass a blower door, we've always asked for it to be kind of sealed from the back, either by a clear electrical tape or clear packaging tape. Some builders would go to an extreme and actually polysil all of these holes. That to me is intrusive to the homeowner. It shouldn't be done that way. It should be avoided at all costs to not have this on an exterior wall or a garage wall that can bring in contamination. Plus in the 24, it now says you're going to insulate the back of it. And it needs to be surrounded by insulation if it's on that envelope. So it's going to be adding to some confusion about if that box is there, how do you treat it? Having to pull those wires all back out and rerun them into another part of the building is not really going to be fun. It's going to cost money. They're going to have to redo some of the wiring possibly. It's best to be avoided and just put on an interior wall. Heat pump supplementary heat. I only put this in here where they just scratched out. It used to say heat pumps having supplemental electric resistance heat shall have controls that except during defrost, they removed that. And it just says are configured to prevent supplemental heat operation when the capacity of the heat pump compressor can meet the load. So they're just trying to say that with the technology that's out there and the things that are happening and the equipment that how they get it put in there, it does still have to go into a defrost cycle. It will have to remove the frost on the compressor to keep running. But then it actually comes down at the very bottom and says, limit supplemental heat operation to only those times when one of these meet. And now that's where they've put in when it's operating in defrost mode. So vapor compression cycle cannot provide the necessary heating. Heat pump is operating in defrost mode, the vapor compression cycle malfunctions, or the thermostat malfunctions. Then it can bring on that supplemental strip heat. Otherwise, it should have whatever controllers that are in there needs to not allow for supplemental strip heat to come on unless you meet one of these four things that are happening. So continuous burning pilot light, it's already been in the code before. They just added an exemption here, but it says gas fireplaces shall not be permitted to be equipped with a continuously burning pilot light. exemption, any fireplace equipped with an on-demand, intermittent, or interrupted ignition pilot light, as defined in that standard, is not considered to be continuous pilot light. So there was some confusion. There was some manufacturer was making one that isn't. I've never really seen one of these in person. I don't know what they look like. But apparently, when you flip the switch, then the pilot light lights, and then it'll fire up and cause that. Once it's turned off, it goes out. So that's probably what they're talking about. It's not considered continuous, so therefore it is exempt from that requirement to not have to have that there. Ductwork located in a wall or floor building assembly separating unconditioned from conditioned shall comply with the following. This is going to address when you see, it's going to bring up a lot of arguments with what is actually intended for this. But if you're looking at duct chases on an exterior wall, a lot of times those duct chases are built so small that the ducts don't have a lot of room. And in order to make more room, they'll remove the insulation out of the exterior wall, and then they'll put the ductwork directly up against the air barrier, the exterior air barrier. This is calling this out specifically and saying that you have to have insulation between the duct and the outer air barrier. This, in my opinion, also would include, if you read the intent, ductworks laying against roof decking. It also needs to have insulation separating it from being in contact with that radiant barrier roof decking, or just OSB or zip board or anything considered as a roof material. It should not be in direct contact. So a continuous air barrier shall be installed as part of the building assembly between the duct and conditioned space. That usually already happens. The duct shall be installed in accordance to this section that talks about duct install and the duct R value. Then it says not less than R10 insulation and not less than 50% of the required R value shall be located between the duct and the unconditioned space. So that's the exterior or the attic, if that's going to be kind of in a floor that way. If it's in a floor and it's facing not a floor, if it's just in some kind of a downturn or a fur down, if it's in contact with any part of the exterior, it needs to be, or the attic space, the unconditioned space, it needs to have R10 insulation there. And then floor ducts and building assemblies to be considered within conditioned space. The air handler shall also be installed in the conditioned space. So this is just talking about, again, back to, you need to have ducts that are not in contact with an air barrier or the outer sheathing. So the radiant barrier that's on the outside of ducts, it's just like the radiant barrier that you install by a fabric or on radiant barrier decking. Its power is that it holds heat and it doesn't re-radiate that heat unless it comes in direct contact with something. So if you put that in direct contact with something on the outside, it will immediately have heat transferring to it at all times. Especially if it's on the roof deck, you've got a lot of heat transferring to it. It can cause condensation buildup inside of the ductwork. So it's best to avoid that by separating it with insulation. I know it's going to be misread where they're going to say R10. They'll have an R10 or an R13 and they'll put it in there and it will be completely crushed at the point of contact. That's not now acting effectively as an R10 or an R13. It's no longer has that R value because it's crushed. There really needs to be the allowance of spacing to allow at least a minimum of R10 to be in between that duct and the exterior envelope. So duct system testing has now moved into a table that better clarifies leakage allowed in different scenarios, such as air handler not installed, air handlers installed in testing, it's in conditioned space, or it's in a foam encapsulated attic. But new to 2024, there's now an allowance for smaller dwellings. So anything less than 1,000 square feet, it's really hard to pass that CFM per 100 square feet allowance because you just don't have enough square feet in the calculation to get there. So now if you look here, it says air handler not installed. If it's a rough test, 30 CFM is allowed. Not how many CFM per 100 square feet. It's just a flat 30. Air handlers installed, it's 40. And then duct systems located in the conditioned space with the air handler installed, 80. So it's allowing that so you don't have to get to that point. So it's kind of using the same methodology, as you can tell. 3 CFM per 100 square feet, 4 CFM per 100 square feet, 80 or 8 CFM per 100 square feet, or it's a flat 30, 40, and 80. So it's kind of using that, but you don't have enough in the calculation to get there. So I think that allowance is great to have in there. There were some above code programs like Energy Star and I think NGBS and possibly Lead follows Energy Star. So some of those programs were already allowing this, and so it was understood that this made sense to put this into code. And but as you can see on the post construction side, it says air handler is not installed NA. Air handler is not installed NA. So that's basically saying by the time you do a post test, the air handler needs to be there. It's not applicable if the air handler is not there because you can't have that same allowance. It needs to be installed so you can test it. Minimal pipe installation's also gone to that level and went to some tables here. It just talks about it now, separates it into different fluid degrees, temperature of fluid. So now it's saying anything really hot, 41 or 141 to 200 degrees, you must have a minimum R value of, it's the same thing, but it's 0.1 per inch for R value for that part of it. This is just where they're introducing this to the table. This may change in the future, but right now it looks like they have the same requirement for both temperature settings. You just have to have that per 1 inch, but it's also doing the conductivity and then the rated system on that. If you read part of that, it talks about the minimum thickness. You also need to look at a different table on the thickness that you need, but it's just talking about the insulation thickness in inches for that. So just 1 inch for that part of it. So water volume determination, this is something new to the code too, and it's going to be a little confusing if you look at the table on, they have to determine the water volume. So the water volume in the piping shall be calculated in accordance to this section. Water heaters with circulating water systems or heat trace temperature maintenance systems shall be considered to be sources of heated water. The volume shall be the sum of the internal volumes of pipe, fittings, valves, meters, manifolds between the nearest source of heated water and the termination of the fixture supply pipe. The volume of the piping shall be determined from this table. The volume contained within fixtures, shutoff valves, within flexible water supply connectors and fixture fitting and within fixture fitting shall not be included in the volume of the determination. Where heated water is supplied by a recirculating system or heat traced piping, the volume shall include the portion of the fitting on the branch pipe that supplies water to the fixture. So looking at the nominal size of piping, if you have a 1/2 inch pipe, then you look to the right across the top and you see what is it made of. So if you have PEX piping all the way at the end, you have a 1/2 inch pipe of PEX piping, you have 1.18 of that volume. That's ounces of water per foot in the tube. So you have to calculate some of that. It'll get a little confusing on the first couple of times you do it. Of course, more than likely, most of it's going to be always that same size, that 1/2 inch or maybe 3/4, possibly 1 inch. You won't really get too many that are larger in residential homes. But this has to now be calculated per volume of that water as well, because that's the more volume you have in the piping, of course, the more water you have to heat, which consumes more energy. That's why it looks like it's talking about water, but it's basically looking at the consumption of energy for water that's being used as heated. So demand responsive water heating, this also brings up some more things. So electric storage water heater with a rated water storage volume of 40 gallons to 120 gallons and a nameplate input rating of less than 12 kW shall be provided with demand response controls in accordance to the table that's on the next page or equivalent approved standard. There is exemptions. It says exceptions here is water heaters that are capable of delivering water at the temperature of 180 degrees or greater. Water heaters that comply with these sections of a different requirement. And then water heaters that are used 3-phase electrical power. So they're just getting more into that, having it on demand. This is a picture of a water heater online that I've not really seen. It looks like a tankless tied to a tank, so I'm not sure, but that's got some demand responsive controls in it. This is what the table looks like. They actually look at it by equipment type. If it's manufactured before 2025, that's July 1st of 2025, and then if it's after July 1st of 2025, then you've got different levels of what it should meet. So different standards. There's level 1 and level 2. And as you see there's on the level 2, it's talking about exempt is also having the price stream communication functionality for that part of it. So looking at that, that's again going to get a little bit more complicated when you're looking at demand responsive controls for water heating. But this is just the stuff that makes it into the code after long consideration and discussion on how to get there. So also a change a little bit into a table is the whole dwelling mechanical ventilation fan efficacy. There was always just this short little version of a fan efficacy table, but now they've made some adjustments here. They took out location, they just say system type. They don't say the airflow is a minimum. They actually look at it's a starting point. It's not just minimum, it's a starting point and goes up. And then of course you've got that watts per CFM as well. So test procedures, they've also put in that as well, talking about before in prior code cycles, there wasn't a test procedure listed. So a lot of people had to ask, there's no consistency there. How do I determine its CFM per watt being used? And so now there's a way to follow a standard process that's listed here on how to do it. Of course, the ERVs and HRVs are the ASHRAE standard 51. There's also a standard 210. And then you've got range hood, inline supply fans, either exhaust or supply, and other exhaust fans need to also follow the ASHRAE 51. And then you've got air handlers. It says outdoor airflow as specified. Air handler fan power determined in accordance to the HVAC appliance testing method referred to in this commercial section on how to test the HVAC for that power wattage. But a lot of times the softwares that the third parties have when they do energy modeling will make that not really that calculation per se. It's a checkbox where if you checkbox it and say you've used the air handler, it's probably going to fail because it knows that it fails the efficacy because of the CFM being used or CFM requirement for the building. So that's a little bit different in how things were done prior. It gives some guidance on the standards that need to be followed when doing testing. So lighting equipment, it changes a little bit as well. So all permanently installed luminaires shall be capable of operation with efficacy not less than 45 looms per watt. I think before in the 21 it was 65. So really what they're doing is taking those, you're just getting, no, it still says 65 with this, but they've added some exemptions here. That's what they did. They added exemptions for here. Before it was always kitchen appliances are exempt from lighting requirements if it's installed per manufacturer. So if you've got lighting on a vent-a-hood, if you've got lighting on a stove, if you've got lighting on a microwave, those lights are exempt from having to meet that 100%. And also they're exempt from having to have this looms per watt requirement as well. But now what they did was add antimicrobial lighting used for the sole purpose of disinfecting. So if some people are installing these in their homes as well, where you've got lighting that will disinfect, those things are also exempt as well. But that requirement for 45 looms per watt or 65 looms per watt for operation is also was the same. So before, when it breaks it up, it's talking about luminaires. So that's the fixture, and then you've got lamps that can be considered for just the bulb itself. So that's how they determine that. If you've got fixtures or lamps, it's called luminaires or lamps. The lighting power, this is a new table in the book as well. They've now brought this into the code. Some of this stuff was brought over from commercial, as we keep seeing things being brought from commercial. It's talking about building exteriors and lighting allowances for residential buildings. Basically, it just talks about like the base site allowance is 400 watts. Then it breaks it down into specific areas, stairways, dining areas. A lot of these things that you see listed, it's for like multifamily, residential, multifamily, not commercial, but multifamily residential. It's talking about building entrances, pedestrian and vehicular entrances and exits have different requirements, entry canopies, dining areas, and things like that. And it breaks it up into base allowance, building grounds, and then building entrance and exits. So different requirements for that. And then for lighting power requirements, so that it lists 3 here. There's 3 different sections. So, but to talk about each one of those, you've got total on the first one, R404.1.2. The total exterior connected lighting power shall be greater than the exterior lighting power allowance calculated in accordance to the table. The total exterior connected lighting power shall be the total maximum rated watt of all lighting that's powered through the energy service of the building. There are exemptions or exceptions for that. It says lighting used for the following applications shall not be included. So that's lighting approved for safety considerations, exit signs, specialized signs, directional markers, marked lighting for transportation, temporary lighting as well, lighting for water features such as swimming pools, lighting for controls in the dwelling units. Those are all exempt for those power requirements. And then exterior power allowance. It says the total area or length of any area type multiplied by the volume of the area type in the table we just previously saw shall be the lighting power in watts that's allowed for each type. So it's one of these things where you're going to have, it's almost getting to, I get questions all the time about lighting commissioning for commercial. These things are also going to start having more questions in residential as who's going to do the commissioning for lighting to make sure that this power allowance and the lighting allowances are being met, and someone signs off that they've tested that and verified that they're installed to be that way. There's also additional exterior lighting power, so it shall be available for lighting facades. It gives a certain watts per square foot of gross area. The additional power allowances shall be used for the luminaires facing the serving the facade, shall not be used to increase any other lighting power allowance. So some of this, when you read it, it looks like it's in the residential section, so why isn't it dealing with regular houses? But as you read the requirement, it's really talking about multifamily residential. And then lighting controls for that is for interior. It says all permanently installed luminaires shall be controlled as required by these sections. Now, this is the two new ones, is habitable spaces and specific locations. Before it just said it had to have lighting controls, but now it breaks it into a habitable space and specific cases. So all permanently installed luminaires in habitable spaces shall be controlled with a dimmer or automatic shutoff that automatically turns off within 20 minutes, and incorporated a manual control that allow occupants to turn lights off and on. For specific locations, now it's talking about garages, unfinished basements, laundry room, utility rooms, shall also be controlled by an automatic shutoff that the automatic turns off within 20 minutes and incorporates a manual off and on control allowed to be turned off and on. So it's just breaking these things apart so that in the future, when you have different requirements for different ones, you've got a different specification for location on those lighting. Exterior lighting controls, there's still a lot of that here. So exterior lighting controls from within individual dwellings shall comply with this section. If you have lighting that's controlled by one control box, but let's say it's a row of townhouses that are all tied together and all the exterior lights are controlled by one controller, then you need to follow a commercial section, which is RC 405.2.7. But if they're all individual, and that was unclear in the 21, now they clarified it and said, then you're going to follow the residential 404.3.1. So that's controls for individual dwelling units where the total permanently installed exterior lighting is greater than 30 watts, then the permanently installed exterior lighting shall follow these below. So it's lighting shall be controlled by manual off and on switch that permits automatic shutoff actions. In other words, it can be switched off and on, but it needs to revert back to automatic shutoff. Lighting shall be automatically shut off when daylight is present and satisfy lighting needs. Controls that override automatic shutoff action shall not be allowed unless the override automatically returns to automatic control within 24 hours. So yes, you can have an off and on switch manually, but it needs to revert back to automatic settings within 24 hours. Another one here that's bringing up a lot of concern and conversations is systems using fossil fuels, water heaters, household clothes dryers, conventional cooking tops, conventional ovens must have individual branch circuit outlets rated as followed. So cooking, household dryers, water heaters all need to have electricity tied in behind it if they're using a gas appliance. So here it gives the rating of 250 volts with 40 amps behind cooking appliances, 240 volts with 30 amps behind household dryers, and then 240 volt with 30 amps or 120 volt with 30 amps for water heaters. And all outlets must terminate within 3 feet of the appliance. So right now, this does not include gas furnaces. So you don't have to have the power needed for heat pumps in the attic. I think I see that coming in the future, but right now, it's if you've got a gas furnace in the attic, then you don't have to have electricity. But all these other gas appliances within the home needs to have electricity behind it. It needs to be within 3 feet of the appliance. And I think some of this is in the IRC or the IBC already. So they're putting the same thing into the IECC for clarification. So renewable infrastructure, so the renewable energy infrastructure, it's for 1 and 2 family dwelling in townhomes. There's these different requirements here. I'll go through each one of those. There's a lot of words to it. I didn't want to take up 3 or 4 slides for it, but you've got solar ready zone area, you've got obstructions, you've got electrical service reserved space, and then you've got electrical interconnection. So the solar ready zone is the total area of solar ready zone shall not be less than 250 square feet, shall be composed of areas of not less than 5.5 feet in one direction, not less than 80 feet, exclusive of access and setbacks areas as required by the IRC. Exception, though, is dwelling units in townhomes 3 stories or less in height above grade plane and a total floor area of equal to 2,000 square feet per dwelling unit shall be permitted to have a solar ready zone of not less than 150 square feet. So there's different requirements there as well for solar ready zones. And then obstructions, it says solar ready zones shall be free from obstructions, including but not limited to vents, chimneys, and roof mounted equipment. Electrical service reserved space is the main electrical service panel shall have a reserved space for a dual pole circuit breaker and shall be labeled for as quote for future solar electric. The reserve space shall be at the opposite load end of the bus bar from the primary energy source. And then electrical interconnection, it says the electrical junction box shall be installed within 24 inches of the main electrical service panel, shall be connected to a capped roof penetration sleeve or a location in the attic within 3 feet of the solar ready zone by a minimum 1-inch non-flexible metal conduit or permanently installed wire as approved by the code official. Where the interconnection terminates in the attic, location shall be no less than 12 inches above ceiling insulation. Both ends of the interconnection shall be labeled for solar, for future solar electric. So they're identifying those spaces, those requirements for those spaces, and how those are going to be handled for residential. And then we've got the electric vehicle power transfer infrastructure. So there's 2 new requirements here. So new automobile parking spaces for 1 and 2 family dwelling in townhomes shall be provided in accordance to these 2 sections. New residential automobile parking spaces for R2 occupancies shall be provided with electrical vehicle power transfer infrastructure in accordance to those same two sections as well. So it's automobile parking spaces for 1 and 2, and then if you have low-rise multifamily apartments, then it's the residential automobile parking spaces for R2 still needs to follow the same requirement for those as well. And if you read those requirements, it talks about the way that is, and this is the requirements that are in those listed for the transfer infrastructure. You've got quantity, you've got EV capable spaces, you've got EV ready, you've got circuit capability, and you've got EV-SE installation, which also has a minimum charge rate. So quantity, it says 1 and 2 family dwelling in townhomes with a designated attached or detached garage or other on-site private parking provided adjacent to the dwelling shall be provided with 1 EV capable, EV ready, or EV-SE installed space per dwelling unit. That does say R2 occupancies or allocated parking for R2 occupancies in mixed-use buildings shall be provided with EV capable space, EV ready space, or EV-SE space for 40% of the dwelling units or automobile parking spaces, whichever is less. And then you've got the capable spaces, and it talks about that. The requirements for that must meet. It's just basically saying a continuous raceway or cable assembly needs to be installed with an enclosure located within 3 feet of the space. An installed raceway or cable also has the size and rated capability for minimum circuit capability. And then electrical distribution equipment to which the raceway assemblies connects to has a sufficient dedicated space and spare electrical capacity for that 2-pole circuit breaker or set of fuses for that as well. So EV ready spaces, it's talking about the branch circuit serving that EV space shall comply with terminating within 3 feet, have a minimum capability in accordance to this different section in the book. The panel board or electrical distribution equipment shall have a directory that basically is labeled already that says for electric vehicle supply equipment, which is the EVSE. And then the outlet or enclosure shall be marked as such. It should either have EVSE or electrical vehicle supply equipment labeled. And then the circuit capacity, it's talking about the circuit capacity. Sorry about that. It's just talking about having that the raceway is still saying if within 3 feet, and it's just talking about the equipment for that part of it that's in there. Hang on, I'm getting to this. Sorry, I messed up. It's just the capacity of not less than 8.3 kVA or a 40 amp breaker at 208 or 240 volt for that space. And that repeats itself a lot in these requirements, is that 8.3 kVA or the 40 amps with 208 and 240 volts for that part of it. But it also references another standard. It's NFPA. It's referencing the standard for that to follow for the actual capacity for that circuit. It's going to start pointing back at some of the electrical requirements as well. And then it says the branch circuit has that rated for that. It's for EV ready. The circuit should be, if it's shared, also has to follow a different standard. So if you're sharing that because it's in a automobile parking spaces not dedicated to a dwelling, then you need to follow that NFPA 70. So it says for exemptions, though, it says where the local electrical distribution entity has certified in writing that it is not able to provide 100% of the necessary distribution capacity within 2 years after the estimated date. So it's going to be, again, more specific on what is exempt and what's not. It's going to be something you'll have to talk to your building official on whether or not you're exempt with that part of it. And then circuit capacity management, it just says the capacity of each branch circuit serving multiple EVSE spaces, EV ready spaces, or EV capable spaces needs to be controlled by an energy management system providing load management in accordance to also that NFPA 70, and then shall have a capacity of not less than at least 2.7 kVA per space. And then the EVSE installation, it also points at UL 2202 and UL 2594 for different occupancies for that as well. The minimum rating for charging, it's showing on here, must be able to be capable of charging of not less than 6.2 kVA or 30 amp breaker at 208 and 240. Then it says we're serving EVSE spaces allowed to have circuit capacity of not less than 2.7 in accordance, and it says it shall be controlled by an energy management system, also capable of simultaneously charging of not less than 2.1 kVA. So if it's going to be sharing and it's one control system, it needs to at least do a 2.1 kVA per space to actually have that fast charging, or at least not a really slow charging for each one of those capacity. I know that's confusing. That's a lot of words. That's a lot that's there. It's going to take a lot of reading and rereading to understand fully. So building simulated performance, it's no longer called total building performance. It's now simulated building performance. It still has a list of requirements of specific prescriptive requirements. The sum of the proposed UA will be not less than, and this is where it kind of gets a little confusing. It's talking about each climate zone has a different allowance to meet the prescriptive UA alternative trade-off. So in 0 to 2, it's 0.108 times the UA, the area. And then in 3 through 8, it's 1.15. So before it was always, it just needed to be at that same level or greater or better. Now it's actually giving you a specific requirement based on the climate zone that you're in, of if you're going to follow the total UA alternative or the UA part of that building, simulated building performance, you're going to have to follow that. Software will do it. It will calculate it based on your climate zone, but that's how you go through that part of it. Simulated building performance as well. We've got buildings without fuel burning appliances for space heating now must meet 85% of the annual cost on the proposed design compared to reference. Buildings with fuel burning appliances for space heating now needs to hit at least 80%. Used to it would say equal to or less than. Now it's actually saying a specific percentage or less than. And then dwelling with units with greater than 5,000 square feet of living floor spaces now has to add an additional 5% better for energy efficiency. So it's starting to penalize larger buildings on the annual energy consumption when you compare the proposed to design, or the proposed design to reference. So you're starting to hit a lower threshold. That's how they just squeeze a little more power out of this energy efficiency. Is you already have efficiency equipment, but now you're going to have to meet a little bit less of a threshold for a percent of annual energy consumption. This is the simulated performance requirements. Also, it's prescriptive requirements table that goes through here. Everything in blue has kind of been either adjusted or added to that part of it. I won't take the time to read all of that, but it's a lot of prescriptive measures that are being followed even when you're following simulated building performance. Same goes for the ERI. You're also looking at tables that you have to go through, and it's prescriptive requirements for those tables that have to be you have to follow. Some of the things, as you see, they are marking some of those out. So as you see, we'll talk about what happened to the additional efficiency packages, but it's gotten stricken out by these prescriptive requirements that have to be for simulated performance and ERI. It was taken out for that part of it, and you'll find out why in just a minute. So it did also adjust the ERI. In Texas, we have our own ERI to follow because the state of Texas has the House Bill 3215 that was added that adjusted the ERI for Texas. But if you read it straight out of the code book, it's dropping at least 1 to 2 points for ERI. But what they did add was to the right, it adds another ERI number that says if you're going to use on-site power generation or on-site power production, this is the ERI number that you need to follow. So before it always just said you can't get to the number in the middle column by using on-site power production. So now they're saying, well, but if you're going to use power production, then this is the number you need to hit or be below in all climate zones. So without on-site power production, you're the middle column. With on-site power production, you're on the right column, and you need to be 40 on the ERI or better in all climate zones. The additional efficiency, we just talked about why that was struck out, because now it's changed it completely. You'll see what it looks like on the next table. So additional efficiency requirements. It used to be those 5: water heating, better envelope, tighter homes, things like that you could do to get your additional efficiency measures. A lot of cities amended those out. Some cities did not. So even though you've met code, you have to do one of 5 additional efficiency measures. They removed that. They moved it to the existing buildings part of the book. But what they did was took what was in commercial and moved it into residential. So it's talking about additional efficiency credit requirements. 2 of the additional measures listed shall be selected from the table you'll see on the next slide to be met or exceed to get 10 credit points. 5 additional credits shall be selected for dwelling units greater than 5,000 square feet of living space. Again, kind of penalizing the larger buildings, but you're going to follow this. You're going to meet whatever code pathway you're following. Then you have to get 10 points. Then you also have to do 5 more additional credits and points if you're 5,000 square feet or larger. And then it says each measure selected shall meet the relevant subsections of section 408 and receive credit as specified in the table 408.2 by the specific climate zone. And that's what it looks like. This is only a portion of it, but it's talking about credits for additional. As you can see, to the far left column, you have the measure number. Then you have a description of what that measure is. Then you have the credit value per climate zone. So if you did an upgraded heater in Texas, you're going to get very little points because we're not heat dominant, we're cooling dominant. So to get maximum points for what little measures you have to do, you need to do cooling. But as it said earlier in the requirement, you need to do at least 2 of these, but it needs to add up to 10 points. So if you do 2 and they don't add up and you're at 7, you have to do a third to get 10 points. And then on the right, I actually started breaking it down on what some of those look like. So talking about enhanced envelope performance, it spells it out on what needs to be done. It basically gives you 3 different options, and it says not less than 2.5% of the building thermal envelope, not less than 5%, not less than. So you just kind of move down that line. Improved fenestration. So now it's adjusting the U factor, it's adjusting the SHGC. And down here on the bottom on the right, you see the improved fenestration table saying per climate zone, this is your improved that you're going to follow. So to get those points, this is what you have to do. So even though it's listing the points and it's not letting you and allowing you just to say, well, how do I get there? What do I need to do? What's my requirement? It's now adding tables and better description of each one of these on how to obtain that. So the next second page to that is another list of this. And as you see, TBD, to be determined, to be determined. They still are factoring this out. They're still trying to assign points. They now have each measure listed, but they're trying to assign the points. They haven't got there yet. Then to the right, you see just another sample of some of these. Minimum roof reflectiveness. You've got service water heating efficiencies. All of this gets brought into which measure am I doing? What is the water heater? Is it gas? Is it solar? Is it electric? And then what's my size or draw pattern of that? And then the type. And then what my efficiency needs to be at or better. So it's just breaking each one of these down. This is the third page to that. It now also throws out that if you do Energy Star appliances, you can also get credit and add those credits in here. So some builders are already meeting a lot of these credits just by the way they build, because there's not a lot of builders that don't build with energy efficient appliances that are labeled as such. But you have specific protocols. It has to be at a certain version or better, which if you build it today and you buy new appliances, you'll meet that. But as time goes on, older appliances will have to be upgraded to the point where they need to get to that part of that. But most builders don't install clothes dryers, clothes washers. They do the dishwasher, but not the refrigerator, which means you're already not getting max points, or you can't get the points because you're not doing all of these. You have to read into that and find out, do I need to meet all of them, or can it just be one? And then, of course, demand response, talking about thermostats, water heaters, demand response. You can get points for that, but it now gets in here and tells you exactly what you need to do and what those things need to function as and what the demand response needs to be in order to get those points. So I know that's confusing. It will be confusing for a lot of people. It has to be determined. This is going to be, in my opinion, a lot more heavy lifting and heavy work for plan reviewers to confirm that those points are being correctly awarded and added up to the sum to get 10 points or more, than looking at square footage of the building. And if it's beyond 5,000 square feet, even more now has to be put in to get to those requirements to meet that base load or the base of energy code. So that's kind of the bulk of that part of it. I know we're about 1 hour, 30 minutes now. I've only got a few more slides to go through. I'll just burn through this real quick. It's existing buildings. They're now bringing things into there that's required for change in space. Any unconditioned from low energy building or unconditioned to condition needs to fully comply. There are exceptions here. If you do a simulated performance and you see it's 110% or less of the annual energy, then it's exempt. But if they don't know and they don't do the report, then really your leg to stand on is all of that needs to now comply. If they take the sheetrock off the wall and do a gut rehab, or they're changing a garage into an apartment, it all needs to come up to that level of what the regular part of the new building codes are, not just looking at existing sections of the book. They've now added those additional efficiency packages based on what it is that you do. But as far as what you do as far as to the buildings, you have exemptions. So it says additions that increase the building's total square footage by less than 25%. Additions that do not include additions or replacements of equipment covered in these sections. Additions that don't contain conditioned space, or where the addition alone or the existing building or addition alone complies with an ERI or performance. So if they run an ERI or performance model, then you don't have to do these additional efficiency packages. But if you're just following prescriptive, which most people do when it's a remodel, then you're going to have to do additional efficiencies. And so building envelope, it says in no case shall the R value insulation be reduced or U factor of building need to increase in the building's thermal envelope. So if you're doing an addition, you can't go less than the energy code requires. You can't throw in older windows and just put a window in it. You've got to meet those levels of requirement. Roofing alterations. So just, I won't go through all of these, but it's talking about roof insulation complies with R402.1 or approved design shall be provided for the roof alteration conditions if this is applicable. It says an alteration of roof construction where there is no insulation above conditioned space, or roof replacement for roofs with insulation entirely above the deck. So what they're trying to get is if you have to replace a roof and there's no insulation in an inaccessible attic space, then you should insulate it before you actually put that back. So they're trying to get lower energy consumption for existing houses, and this is one way to do it. Above grade wall alterations, I just kind of threw this from directly from the draft into here. Like I said, we won't spend a lot of time going through each one of them, but they're addressing things specifically when you're looking at gut rehabs or additions or alterations to a building. They're now spelling out what needs to be done. Before, a lot of times it was when I was doing inspections, it was, is the building better? Yes. Do they need to meet energy code? Not really, because it's an existing building. But now the existing chapter is now having to address all this to have it come up to that code level, depending on how much is being done. Same thing for floor alterations. Those as well. If you have floors that overhang exposed cavities or surfaces where you can actually start adding insulation to it, if you're actually exposing that, it needs to come up to that level. Even though someone says, I'm not removing the floor, I just took the sheetrock off, or I took the outer cornice board off, I took wood to replace because it was rotten. Well, you need to insulate it before you put those back. Below grade walls, that's another thing they brought into with basement walls. We don't see a lot of basement walls in Texas, but there are requirements for below grade space for conditioned spaces as well. They've started to address that. The air barrier, same thing with that. If you have a house that's being a gut rehab and you pull the sheetrock off, you pull the insulation out, and you see an air barrier that's there, it could be felt paper, it could be press board, it could be OSB, it could be anything. A lot of times if I didn't do anything with it while I was doing the improvements, I could just insulate over it. This says, no, if the building thermal envelope assembly is altered in accordance to the R503.1.1 shall be provided with an air barrier in accordance to the R402.5, which is the new construction requirements, is you need to have an air-sealed air barrier. The air barrier shall be required to be continuous with unaltered portions of the building's thermal envelope. However, there are exemptions in there that says if you can't get to all of it because some of it's not being removed, then you're exempt from that part of it. Then it says testing requirements of R402.5.1.2 shall not be required, which is blower door testing. So there is an exemption there that you don't have to do that. Heating and cooling system, that says new heating and cooling system and duct systems that are part of the alteration or the addition shall comply with 403, which means insulated ductworks to an R8 in unconditioned spaces. But then it says exception here, where ducts from the existing heating and cooling systems are extended in an addition. So if you're just adding ductwork to it, it's exempt. But if you have an alteration, say you're doing a garage and you're adding this, all of it needs to comply with the new requirements for that. HVAC ducts newly installed as part of the alteration shall comply with 403. And again, it's the same thing I just read there, but if it's part of the addition, it doesn't have to comply. But if it's new equipment being installed, it has to be R8. So sizing of the equipment, manual J, manual S. This is what it's talking about in the new building codes. It's talking about you must do a manual J, manual S load calculations for proper sizing of HVAC. Now it's brought into the existing buildings, and it says any new and heating and cooling equipment as part of the alteration shall be sized in accordance to that same section, which talks about manual J, manual S being done for that. So if you have alterations, additions being done, the alterations, especially if they're replacing the equipment, needs to have that. Of course, it says where it's demonstrated by the code official that compliance with this section would result in heating and cooling equipment that is incompatible. In other words, if something is inaccessible, but you're replacing the other that is accessible, they should not be made to have to all match up and be meeting that new requirement. So you have to look at part of if it's all acceptable, if you can reach some of that and it's accessible. So duct leakage, now they're talking about alterations. It includes following the duct testing shall be required to be done. It's allowing 12 CFM per 100 square feet, not 4, not 8, which is in unconditioned space and in conditioned space. Now this says you're allowed 12 CFM per 100 square feet. But also it says where 25% or more of the registers that are part of the duct system have been relocated, you need to have it duct tested. Where 25% or more of the duct system is increased in size, you need to duct test it. Where the total length of the duct also is increased by 25%, needs to be tested. Exception though is duct systems located entirely in the conditioned space. So the new code says if it's entirely in conditioned space, you still have to duct test it. However, if you're part of an addition or a remodel, it's saying if you're in conditioned space, you don't. We've got a question here that says, receive questions about new requirements from the Department of Energy for 2023. Are you familiar with those requirements? Requirements specifically, sorry, I just now looked at the chat. So if you'll put what that's focused on, I can maybe talk about that in just a second. So controls, this is just talking about if you're changing out a system, if you don't have a programmable thermostat, you need to now have a programmable thermostat that meets the requirement which is R403.1 for controls. It needs to also have that. And then, of course, the 403.2 is water heater boiler temperature reset. That 403.1 is controls for programmable thermostats, HVAC efficiencies. We can talk about that in just a minute. As always, I'll end the recording when this webinar is over, and we can just talk about it from there. But if not, we can talk offline and get more specific with that. So yeah, I am familiar with those, and we can talk about what you're looking to try to clarify with that part of it. Additional efficiency packages. So in alterations, shall comply with R506, which is the additional efficiency package, where the alteration contains replacement or 2 or more of the following. So it's talking about water heating, light fixtures, 50% or more, 50% or more of the internal area. Interior of the area has the thermal envelope work was done. If 50% or more of the building's exterior wall envelope was taken off, now that needs to be have additional efficiency packages done to it. Exceptions is alterations that are permitted with the addition complying with a different section, and then alterations that comply with different sections as well, which is the performance path or ERI. If you do a performance or an ERI, you don't have to do that additional efficiency packages. But what they're getting to you as, if you don't really know the outcome of what you're saving in energy consumption or proving it by a performance path or ERI and meeting those requirements, then you're going to have to do an additional efficiency measure. And then just 2 or 3 more slides with just repairs. What it's talking about is even when you're doing repairs, you also have additional efficiency packages. This is where it took the 5 from the previous section of the book in chapter 4. It took those 5 and brought it into chapter 5 to add it to the repair section. So enhanced envelope performance, more efficient HVAC equipment, reduced energy use for water heating, efficient duct thermal distribution or putting it in conditioned space, and then improved air sealing and efficient ventilation systems as well, using an ERV as opposed to just a standalone fan or the air handler as your fan unit. Then you have to look at that part of it. So 502 is additions, 503 is alterations. So if you're doing either one of those, it says you must also do an additional efficiency package. And then the last one I'll have on here is we do now have appendices that were added. We have appendice RC, which is a zero net energy pathway. We're calling them kind of a glide path. They're still trying to get to that net zero by 2030. So they're starting to set this up with glide paths to get there. So you've got zero net energy appendix. You've got electric energy storage appendix. You've got all electric buildings appendix. Then you've got an alternative building thermal envelope insulation R value option. So there are different ways that you can look at it and actually follow that. But if you're doing an all electric building, by all means, take a look at the appendix RE and look at some of the requirements that can go in there. These are optional because all appendices are optional. But if you're trying to get to that net zero, you can follow that logic. Electric storage, you can follow that appendices and down the line to actually get to those requirements that are there. So I know we ran a little bit long. This is my contact information. By all means, screenshot it, snapshot it with your phone, take a picture of it, share it with anybody that you want that I can help with. If I can help with the understanding of the code, especially when the 24 hits, or if you're a new city, or if you're a city that has now newly adopted the 21, navigating that and having builders understand that sometimes can help. I get calls a lot of times from developers that are out of the state coming to Texas that have to deal with how Texas is with the home rule, having different cities being on different code levels, and they don't understand what the requirements are from each. I can help with that. If you want to reach out to me and schedule a training with either your organization and or your city, by all means, email me, phone me, text me, whichever one you want to do, and we can get something set up for that part of it. So we have a raised hand here. Hang on one second. All right, Cody, you should be able to talk if you unmute yourself.
Hi, how's it going?
Good. How are you?
Good. Without trying to confusing things any more than it already is, can you explain a little bit? Because I mean, we talked. You said earlier that depending on, regardless of the approach of the performance base that you're going through, these are the minimums. But yet also, Energy Star is also another performance pathway that you can go to, and Energy Star is going to change in 2025. So without trying to confuse anything, what are going, or maybe this is another class, but they're going to need to know that there's a difference between the Energy Star compliance than what the new energy code is going to be requiring. And do we know what those completely differences are going to be when the new Energy Star in 2025 hits? Because I'm hearing that in this climate zone, it could be an R20 plus 5 on the envelope. And since a lot of the builders are going through Energy Star in order to get tax credits, I'm just trying to figure out what kind of the impact that's going to be to the building department to know the difference between what Energy Star is requiring and what the building the codes are going to be requiring.
Nope, that's a great question. And as I always say, I mean, Energy Star is a completely standalone compliance path which can be followed, and none of what I just talked about would be required. However, I've not fully read the 3.2 version of Energy Star to see what those new requirements are. I do know that it actually looks at the 2012 instead of the 09 as its backstop. Of course, in Texas, it's 2018 because that's what's in the requirements. But as far as the 20 plus 5, I wouldn't be surprised for Energy Star to go that direction, but I have not yet read that, Cody. I have not. But to clarify what you just said, yes, all of what I just talked about is any pathway followed in the code book. Energy Star is a completely different animal and does not require anything else with that. Oh, hang on one second. We've got somebody. Connor Dillon's on here. He says he's got an answer to that. Connor, you should be able to unmute yourself. Thank you.
Hey, can you hear me?
Yes, sir.
All right, perfect. So just to answer this real quick. So Energy Star single family new construction version 3.2 has the insulation backstop of the 2021 IECC. It also references for their calculation the climate zone map of 2021 IECC. And in general, for what it's worth, the way that Energy Star always handles things is they will denote if there is conflicting requirements on a specific item. So let's say ceiling insulation, you have to go with whatever is more stringent. So if a city adopts in Texas the 2024 IECC and they now do R38 instead of the R49 or whatever it is, Energy Star would say, hey, you have to do the R49 because that's our thermal backstop that's more stringent. Does that make sense? In general, right?
Yes.
I'm not, gonna sit here and speak for the EPA or anything like that, but in general, that's how they handle things.
Got it.
Now I've got to go, but if anyone has any questions, Randy knows my contact information, can pass it off.
Absolutely. Thanks, Connor. I appreciate that. Cody, did that help?
Yeah, I mean that was kind of where I was trying to get at, because it's a little bit more, it gets a little more confusing when you start adding Energy Star as your pathway. And
Absolutely.
maybe that's a different class to make sure that the building departments understand that if they do go down Energy Star pathway, that everything that we're learning here could be different, and want to
Correct.
make sure they know what they're looking for before they go down this pathway. Because if I'm not also like he said, whatever is more stringent, because now the ACH changes as well. And then, like you said, the climate zone map is going to change, because now that climate zone map goes up into the DFW area, rather than stops at Waco. So there's a lot of different variances when it comes to the builders trying to go for tax credits, which is something that they're just going to go after regardless because they got 10 years to use it versus going to the codes, and that can be even more confusing. And that's why I wanted to make sure that, you know, if it sounds like a different class that we may have to take later on down the road, but it's
Yes,
something I wanted to
yes.
point out.
Yeah, and it will be that way because what we're going to do is as it gets closer to that, and once hopefully Texas finally gets to a new adoption, of course, now the clock's on. It's 365 days till they have to update it. So we'll go through that 3.2 version so that building officials and inspectors can know what to look for. But you're right, this is just getting more confusing, and that's kind of why we're going to be here to help. So yeah, thanks,
And
Cody, for
and,
that
and
question.
everything that you mentioned in this class, this is based upon the IECC. This has nothing to do with the amendments that may come through the state of Texas, correct?
Correct. Or any amendments made by a city.
Gotcha. Okay.
Yeah. Yeah, it's specifically for how the book's being written. If anything changes or the state adopts or amends something, or cities adopt or amend something, that all can change. Yeah, this is just straight out of the book. All right, I will stop sharing now. Whoops.